Good morning, fellow mathematicians! Welcome back to another video. We finally reached one of the climaxes here on this playlist on linear functions. We would like to go into detail about combining the slope and our y-intercept, meaning we are going to deal from today on with linear functions of the general kind, of the form ax plus b. And if you don't know some of the prerequisites, what for example the slope is or the y-intercept, make sure to check out the link at top of the description and also in the info box. It will lead you right to the playlist where you can find all the videos. So if you are not prepared yet, take a look at all the other videos that came before this one and you are going to be well prepared for what we are going to do today. So, linear functions of the general kind. We have learned about the slope before and our y-intercept, and we would like to combine those two today. And at first I would like to go back a tiny little bit to the so-called identity function. It was the one mapping items or element, I should rather call them elements, from the domain to the codomain by the same value. Meaning 1 has been mapped to 1, -1 has been mapped to -1, and our identity function was this boy right here, going right through the coordinate system's origin. And we want to use it for comparison purposes, and now we are going to construct ourselves a general function and see how a and b at the same time act on this linear function. Meaning, let's say we are going to have g of x being equal to, okay, let us go with one, I don't know, 2x plus 1. And now we are going to see how the slope and the y-intercept are going to affect the outcome, so the graph of this function in general. So, what could be the first step to actually plotting this thing? I mean, we need to put points into this graph such that we can play connect points and get ourselves a trend line. How many points do we need exactly? Well, here's a thought experiment again. If we were to put few points here on this chalkboard, how many would you need to connect those in order for you to uniquely determine your linear function? I mean, it's obviously 2, because if you have 2 points and you connect them with your ruler, for example, you are going to get your linear function out. Meaning we are going to get ourselves 2 points. There's one point especially which is really easy to find. Exactly the one where our linear function cuts through our y-axis. And this was exactly the value of our y-intercept. Namely, what you are going to do is, you are going to put your hand on the first part, cover it up. And what you have here is exactly the spot on the y-axis where our linear function is going to cut the y-axis. It's going to be moved upwards by 1 unit, our linear function. This is what we find out when playing around with the y-intercept. Meaning, it's exactly at 0, 1. You can get the same result by plugging in 0 as the x value into this function. Then you're going to get 2 times 0 is nothing but 0 plus 1 is nothing but 1. And hey, there you go. Y-intercept, thank you so much for being there. Now we need another point, and yeah, you can basically plug in each and every x value that you wish for. Meaning, what you can do is, you could say, let's plug in 1, for example. It's an easy number. What about g of 1? G of 1 is hence, okay, putting the 1 into each and every x on this side gives us 2 times 1 plus 1. 2 times 1, if I have 1 times 2 apples, then I have 2 apples. 2 apples, adding 1 more apple to it gives us 3 apples overall. Meaning, 1 and 3 is another point that we can mark here in this coordinate system. Okay, 1 and going upwards to 3. Hey, we got 2 points. We can now finally play connect points. And we are going to connect those. And you are going to notice that overall it's going to cut right through our identity function. Meaning, in this case, our slope is actually bigger of this function than the one of the identity function. Also, it's an increasing function, which does make perfect sense if you think about it, because our slope is 2. The slope of our identity function was exactly 1, meaning it has a bigger slope, and also it's increasing because it has a positive sign, our slope. And here, this right here is one function that you could possibly plot into a coordinate system. What about another linear function? Let us take a look at h of x. And now we are going to take a more spicy example, let's say a -1/2 x plus, let's say -2, okay? This is what we are having here. And now once again, at first we are going to create ourselves the easiest point that we can possibly find. Covering up the first part gives us -2 as being the y-intercept. Meaning our linear function is going to cut exactly through -2 on the y-axis. Okay, now we need a second point. Now we have -1/2 here. Students don't like 1/2s, and I don't suggest putting 1/2s into coordinate systems because there's always an easier way to get an integer out on the other side to make your life a tiny little bit easier. For example, Which number would we need to put into x, for example, to eliminate the 2 down here? Well, each and every even number that you can come up with, because they are divisible by 2 by definition. Meaning what we can do, we could put 2 into our x. So let's say h of 2 is going to be, okay, 2 into here, it's going to give us negative 1/2 times 2 minus 2. Okay, 2 and 1/2 is going to cancel out, leave us with negative 1, okay, and then negative 2. Then we are going to be 3 apples in that, meaning we are going to get negative 3. So there's another point here on this graph, namely 2 and negative 3. Let us look for this point. Okay, we're going to get 2 and negative 3 is down here. Now we are going to connect those two and we are going to get something like this. Okay, good here. So we got this. That was easy, right? I mean, that was really easy to plot. This right here is our h, and once again you can qualitatively, whatsoever, you can take a look at what the slope has been and you can compare with your graph if it fits our requirements that we have found out before. Namely, we are going to have a decreasing function, meaning our slope has been negative, which does make sense because it was negative 1/2. Also, it's slightly less increasing than our identity function being kind of mirrored at our y-axis. Meaning if we were to put this into here, then you might notice that our negative identity function, you could say, goes steeper upwards than our other function. It's kind of weird holding it like this. I hope you can see the point. And yeah, this basically concludes it, and we can take a look into more insights over on Desmos. Alright, we are going to go for a few Desmos insights. And as always, I plotted the identity function to the coordinate system for comparison purposes. It just makes visualizations of the other functions a tiny bit easier. And also we have our generalized linear function here, and yeah, we can now play around with the parameters a bit. So what was the first situation? We were increasing our a and it was 3 with our first example, or 2. I can't remember, but it really doesn't matter. The point is the same here. If we have a slope which is bigger than the one from our identity function, so bigger than 1, for example 2 or 3 or 1000, our function is going to go steeper and steeper upwards, lies above our identity function in the first quadrant. If we were to reduce our a to, let's say, 1/2 or 0.6, we're going to get something that lies between the identity function and the x-axis. If we now have the situation that we are going to go to negative 1/2, for example, this was the one that we had last, then you might notice that if we were to introduce the negative identity function, that we are going to get a slope which is not as steep as the one from the negative identity function, but we are going to have something really close to the x-axis in some way in the second quadrant this time. And it really doesn't matter what our y-intercept is, we can play around with it. So we can move our function upwards and downwards however we wish. And it doesn't matter if we increase our a, we can move it downwards and upwards however we wish by playing around with the y-intercept with the b value. And this basically concludes the tiny little Desmos insight. I'm going to give everything back to Papa Flemmy to conclude the video. I thank you guys for watching. If you enjoyed this video, please like, subscribe, make a comment, channel flag. If you want to support the channel a bit more, buy those t-shirts I created, support channel on Patreon, go over to the main channel and take a look at those videos too. And until the next video, I wish you guys a flammable day. Ciao!